Hello everyone, welcome to this video. In this video, we are going to solve the questions from the engineering mechanics and theory of machines topics, which were asked in the ISRO 2017 set 2 paper of mechanical engineering. There were total 11 questions asked in this paper. Let's solve them one by one. Coming towards the first question, this is from the mechanics topic, trusses. The force in the member BC of the steel truss structure shown in the figure below is the cross section of each member is A and the length of each member is L. So we can clearly see the members have the length L and they have given the cross section as A, and the loading is also provided in this figure. So yeah, we know the problem of trusses can be solved by using either method of joints or method of section. Whenever we have the bigger structure and the member is like, let's say, in between this, which is in which we are supposed to calculate the force, then we generally prefer the method of sections. If a small stress structure is there, then we use the method of joints. So we can basically cut the section passing through member BC, in which force is desired to be calculated. So let's cut this section. It will look like this. And yeah, we can draw the free body diagram of either side. So in this case, let's draw the free body diagram of the right hand side. So it will look something like this. Yeah. We have P2 force in downward direction. Then we have one more P2 force at this point. We have 2 P1 force at point D. Let's write this as C, this as D, this as G, H, and I. Okay, so this is F CB, F GB, F GF, we can say. Yeah, so this is how the overall arrangement looks like. And now we are supposed to calculate the moment. We are supposed to calculate the force in the member BC. So if we take the moments about point G and equate it to 0, then the moment will be created by the force in the member BC, with which is at a distance L, and that is a counterclockwise reaction. In order to balance that, we'll have the two clockwise reactions coming from this 2P1 and P2. P2 will P2 multiply by 2L and 2P1 multiply by L. So it will be like 2 times P1 plus P2 multiply by L. That will be F CB into L. LL will get cancelled. So force in the member BC is 2 times P1 plus P2. Hence option C is correct in this case. Okay, we have just used the method of section in this case and then applied the equations of equilibrium in order to solve this problem. Coming towards the next question. This question is again from the mechanics. A bar AB, this is the bar AB, which is having weight of 10 kgs per meter. So yeah, it's a uniformly distributed distribution of weight is there, and supported by a cable AC like this, and this bar is pinned at B. They're asking us to find the reaction at point B. So again, if we draw the free body diagram of this bar, including the tension in the string, whatever all the reactions it is having, let's see how it looks. This is the bar AB. The point B is hinged, so it will have both horizontal reaction and the vertical reaction. At point A, we have a tension at a 30-degree angle. It is connected to the point C, so at 30 degree we'll have a tension. So this is T cos of 30 degree, and this is T sine of 30 degree. Then we know that the bar is having certain weight, that is 10 kg per meter. So the distance is 2 meter, so it will be, if we assume G as 10, which they have mentioned, so it will be like 100 kg per meter, and it is a 2 meter bar, so we can say 200 kgs of weight, and that CG will be at the center. Since it is a uniform, we can say that here 200 Newton force is applied, or the weight is applied. So this is how the free body diagram looks like. And yeah, at this point, what we can do is we can apply the equations of equilibrium. That is summation of all horizontal forces equal to 0, summation of all vertical forces is equal to 0, and solve it. Summation of all horizontal forces will be equal to 0. So this gives us HB, horizontal force or horizontal reaction at point B, has to be equal to T cos of 30 degree. We don't know the value of T. In order to calculate the value of T, we have to take moment at certain point. Let's say the point B here. If we take the moment at point B and equate it to 0, the T cos 30 will not create any moment. However, the T sin 30 component of the tension will create a moment clockwise, and that is balanced by a 200 Newton force in a counterclockwise direction. So this is the clockwise, and this is the counterclockwise moment. So T sin 30 is 1 by sin 30 is 1 by 2. 2 will get cancelled, and yeah, so tension will be 200 Newton. Using this value, horizontal reaction at point B will be 200 cos of 30, which is yeah. Yes, so which is, yeah, let's keep it as it is. I think maybe it will be 173.2. It will be 173.2. So it is like 200 into root 3 by 2. Let's keep it as it is for the time being. So the next equation of equilibrium is summation of all vertical forces is equal to 0. And that will be what it will give us is we have one vertical force here, we have another vertical force here, and we have one more vertical force here. So VB, which is going upward, plus T sine 30. So it is 200 sine of 30 going upward. That is equal to 200, which is coming downward. 200 sine 30 is 1 by 2. So this will become 100, and VB will be equal to 100. Yeah, and if you solve this, here also this will become 100 root 3. Root 3 is 1.73, so it will be 173.2 Newton. I think it is also correct. So yeah, we got horizontal reaction, we got the vertical reaction. The resultant will be under root of horizontal reaction plus vertical reaction. So yeah, or even if you keep it as 100 root 3, its square will be, let's keep it as, for simplicity, we'll keep it as 100 root 3. So 100 into root 3 whole square plus 100 square. So 100 square, if you take common, it will be 100 outside the root, and in between we have 3 root 3 square, which is 3. 1 square will be 1, so it will be like under root 4, which is 2. It will be 200. So 200 Newton is the resultant force, and the angle they are asking. Let's see. We have two options with the 200 Newton, and let's calculate the angle. The resultant will be tan inverse of y by x. Y is 100, and vertical reaction, that is VB by Vx, is 100 root 3. So tan inverse of 1 by root 3 is 30 degree. Hence, the option B is correct in this case. Coming towards the next question, this is from the dynamics topic, we can say, mechanics when body is in motion. A point moves according to the relation x equal to 8t square cos of omega t and y equal to minus 4t cube sine of omega t, where x and y are in meter and t is in second. If the angular velocity omega is 8 pi radian per second, the velocity vector of the point at t is equal to 0.5 seconds is given by. So we got the value of x, we got the value of y. The velocity in the the horizontal component of the velocity is u, that is dx by dt, and that is the vertical component is dy by dt. If we calculate it, because the velocity vector is given by u plus vi, where u is dx by dt and v is dy by dt. So we already know x and y, so you should be able to calculate dx by dt. That is 16 cos of omega t let me correct it, 16t square, 16t, sorry, not t square, it will be 16t cos of omega t, and then minus 8t square, will keep it as it is, and differentiation of cos of omega t is minus sine of omega t. So that's why minus I have written here, sine of omega t into omega will come. So coming towards the differentiation of y with respect to t, minus 12t square sine of omega t as it is, minus 4t cube as it is. Differentiation of sine omega t is cos of omega t into omega. So this is how it will look. So overall velocity vector, I'll write here. Velocity vector v is equal to u plus vi. So that is equal to 16t cos of omega t minus 8 omega t square sine of omega t. So this is our u part plus I times v part is like minus 12t square sine of omega t minus 4 omega t cube sine of omega t. The question, they have clearly mentioned that they want us to find the velocity vector at a point t is equal to 0.5 and omega is equal to 8 pi is given. But at t is equal to 0.5 and considering omega is equal to 8 pi, we will be able to solve it. So it is 16, t is 0.5. So yeah, 16 into 0.5 is 8. Cos of omega e to t, omega is 8 pi, t is 0.5. So it will be 4 pi minus 8 omega. Omega is 8 pi. So let's 8 multiply by omega is 8 pi. T square is what? 1 upon 4. So it will be 2 pi sine of 4 pi. I times minus 12 t square. So it will be minus 3 sine of 4 pi minus 4. Omega is 8 pi. T cube. 8 get cancelled. So it will be 4 pi sine of 4 pi. Let me correct it. I think the last term was cos omega t. This is cos. This is cos. Yeah. 4 omega t cube, cos of omega t. So something like this it will look. So from this sine terms, you can cancel it out. What is remained is 8 cos of 4 pi plus g, or let's say I times minus 4 pi cos of 4 pi, because sine of n pi is 0, right? So using that, you can make it 0. These two terms are 0. Cos of 4 pi is 1, so it will become 8 minus 4 pi I. Hence, the option is option C in this case. Correct option is option C in this case. Coming towards the next question is from the vibrations topic. We have a cantilever beam of cross-sectional area A and the moment of inertia I and the length L having natural frequency omega 1. If the beam is accidentally broken into two halves, the natural frequency of the remaining cantilever beam omega 2 will be such that omega 2 such that omega 2 is less than omega 1, greater than omega 1, or equal to omega 1, or can't be determined. Let's look into it. We know that omega is K equivalent divided by M, or you can also calculate it as, for the beams, it is G by delta. Delta is the deflection. Deflection in case of cantilever beam is PL cube divided by 3 EI. So the natural frequency is equal to 3 EI G divided by PL cube. So omega, you can conclude it as inversely proportional to the or let's say under root of L cube. Inversely proportional to the under root of L cube. You are breaking this beam into two pieces. So L will become L by 2. Omega 2 will be omega 2 divided by omega 1 will look something like this. Under root of L1 square divided by L2 square, right? L1 is L cube and L2 will be L by 2 whole cube. So it will become 2 root 2 and L cube gets cancelled. So omega 2, you can say it as equal to 2 root 2 times omega 1. So in general, omega 2 is greater than omega 1. Hence, the correct option is option B in this case. Coming towards the next question, this is a theoretical question from the theory of machines topic, gears and gear trains. Which one of this is false? They are asking. Reverted gear train is one in which the first and last gears are on the same axis. It's true. The train value of a gear is the ratio of product of driven to numbers to the product of driving tooth numbers. This is wrong. This is the definition of actually the speed ratio. However, whenever we talk about the train value is 1 upon speed ratio. In terms of teeth, you can say it as T1 by T2. That is, T1 is the driving gear, and T2 is the driven gear. So you can write it like this, or the other, in terms of speed, it will be N2 by N1. So in this case, this would have been correct statement if they mention it as a driven tooth numbers to the driving tooth. The driving tooth numbers to the driven tooth numbers. T1 is the driving. However, they have mentioned it as a driven tooth numbers to the product of driving tooth numbers. Hence, this is incorrect option out of the given. The option C is like the planetary gear train is one in which axis of some of the gears may have motion. Yes, correct, because the planet gear rotates around the sun gear, so axis of that gear is changing or in motion. And the last option is the compound gear train is one in which two or more gears are on each shaft. That is also correct. Coming towards the next question, again this is a theoretical question. Which of the following is not true? For direct impact of two bodies, coefficient of restitution is the ratio of relative velocity of approach to the two bodies to their relative velocity of separation. This is incorrect statement. So you can, at this point itself, you can decide the answer. Let me explain you. The coefficient of restitution is actually a relative velocity after collision or after separation, you can say, divided by relative velocity before collision. So if we have two masses, let's say mass two bodies A and B, these are the initial velocities, so UA and UB, and after their collision, let's say the bodies A and bodies B are moving with a VA and VB. Okay, so in this case, you can write it as VB minus VA is a relative velocity of between them divided by UB minus UA. So this is how you will calculate the or UA minus UB. Whichever is the bigger, you have to take it. So ultimately, it's like a relative velocity. It's the difference between the two velocities. So it's like after collision to the before collision, whereas they have mentioned here velocity of approach to the separation, which is incorrect. So correct option is option. The not true option in this case is option A. Other things looks correct, like about the angular momentum remains constant unless we don't apply the external force. Law of linear conservation is sum of all the external forces in that direction is 0, and the coefficient of friction is independent of area of contact. So coming towards the next question, this is from the mechanics again. The block is given of cross section 4 by 4 meter height and 3 meter in width. A 20 kg mass it is having, and it's rest on a flat horizontal surface as shown in the figure. The coefficient of friction between the block and the surface is 1 by 4. And what they are asking is the force F, which will cause the block to move approximately by approximately. So that that is given by. They are asking us to find the value of F. Let's try to draw the free body diagram of this block. So if we draw the free body diagram, we can clearly see uh, the weight of the block acting in downward direction, 20 kg. So it is 20 into 9.81 Newton. Weight. We have one force which is in the, let's say this is the force F they are asking us to calculate, which is at a 30-degree angle. So the component of this force will be F sine of 30. The horizontal component will be F cos of 30. We'll have normal reaction because this this block is kept on a surface, and it will also have the frictional force in the opposite direction to the force, is mu into n. So this is the overall diagram. Let's look into the details. If we apply summation of all the vertical forces equal to 0, we can clearly see F sine 30 plus normal reaction has to be equal to 20 into 9.81. So the normal reaction can be written as 20 into 9.81 minus F sine 30. Sine 30 is 1 by 2. So here by 2 we can say in this case. So this is the normal reaction. Using the summation of all horizontal forces equal to 0, we can say that F cos of 30, which is acting in left hand side direction, has to be equal to the mu, which is 1 by 4 times the normal reaction. Normal reaction we have just calculated, it is 20 to 9.81 minus F by 2. So F cos of 30 is under root 3 by 2 minus this 1 by 4 goes inside, multiplies with F by 4, gives us the F by 8. So it will be 1 by 8. And that is equal to this 4 cancels out with this 20, you will get 5 into 9.81. So if we further simplify it, this part is almost equal to 0.99 something. Hence, you can say that F is equal to 5 into 9.81 Newton, or it will be 5 kilogram of force. Okay. If I go back, the options are not in Newton, it's a kilogram of force. So the option C is correct in this case. Coming towards the next question. Yeah, this is related to the displacement. We have the, let's say a point P moves along a path y is equal to x square minus 4. This is how the particle moving, and they are asking us to find the displacement of the point when it moves from x is equal to 0 to x is equal to 3. So we can calculate y of 1 and y of 3. Y of 1 is minus 3 and y of 3 is 5. That is 9 minus 4 is 5. So we can say that we can plot it on a graph quickly. This is the first point is at x is equal to 1, the y is minus 3. Something here, 1 comma minus 3. And at x is equal to 3, y is 5. 3 comma 5. So this is how the displacement looks like. And yeah, if we calculate the displacement, you can clearly say that this displacement means the distance between straight line distance between these 2 points, y2 minus y1 whole square plus x2 minus x1 whole square. So 5 minus of minus 3 whole square plus 3 minus 1 whole square. So we will end up with the under root of 8 square plus 2 square is under root of 68 is 8.24. You can clearly take the option A here. We will also calculate the angle. This angle or the slope is tan inverse of y by x. The y is 8 here, right? Is tan inverse of 8 by 2 is tan inverse of 4. So the correct option is option A in this case. Coming towards the next question. A pulley system shown in this figure has mass of 1.5 kgs and the radius of gyration is 0.2 meter. The angular acceleration of pulleys, they are asking when the suspended masses are released. So first of all, the moment of inertia we can calculate for this pulley is like by using this data 1.5 kg is a mass. This is mass into the radius of gyration is 0.2. So I1 will be equal to mk square, that is 1.5 into 0.2 square, which is equal to 0.06. However, there are two other bodies or two other masses attached to it, which are at the different radius, 0.1 and 0.2. So that will also create a moment of inertia. Because of it, we have to consider, let's say m2 r2 square and I3, this is I2, let's call it as I3 will be m4, sorry, m3 r3 square. So it will be like 1 is from 1 kg, it will be 1 into 0.2 square, and from here it will be like 3 into 0.1 square. So 0.04 and 0.03. So uh, why we are calculating it? Because the body is in motion, it will not be in rest. So in order to apply the equations of equilibrium, we can use the D'Alembert's principle. The total active torque will be in the will be in any one of the direction, because let's see whatever is the moment it is generating. The moment on the right hand side will be 3 into 0.1. On the left hand side, it will be 1 into 0.2. So the basically the pulley will rotate in clockwise direction. And in order, if we imagine a counter torque of I alpha, then we can say that body is in dynamic equilibrium and we can apply the D'Alembert's principle. So considering that, we can say that I1 plus I2 plus I3 into alpha has to be equal to the total resultant torque in this case. So it will be like 3 into 9.81 because the masses are in kg into 0.1 minus 1 into 9.81 into 0.2. So alpha can be calculated as 3 into 9.81 into 0.1. So 9.81 you can take it out. It will be 0.3 minus 0.1. So it will be 0.3 minus 0.2. It will be 0.1 divided by the total will be 0.13. So the answer is like 10 divided by. So this is like they are assuming it as 10 rather than 9.81. Let's consider it as a 10. So 10 divided by 0.13. 10 divided by 1.3, because yeah, this you can cancel, and 10 divided by 1.3 you can write. So correct option in this case is option B. Coming towards the next question, it is a theoretical question. In a dynamic balancing of the machines, which of the following is not a method of measuring the magnitude and location of correction weight for two plane correction? You know that there are the methods which can be used for measuring the correction of for two planes are pivoted cradle method, which is correct. Then second one is the mechanical compensation method, and the last one is a nodal point method. The incorrect option in this case is pivoted compensation method, which hence uh, since they are asking a not a method, means the option C you have to choose from this. We have a last question. What this question is from the vibrations topic. Let's try to understand it. Which of the following is true for vibration of a mechanical systems? The first option is damping ratio is the ratio of critical damping to the actual damping, which is wrong actually. You know this zeta is equal to C by Cc. So it's a damping, actual damping to the critical damping. So it's a reverse. So this statement is incorrect. The second statement is the damping can be obtained from the response of a system under a forced vibration using logarithmic decrement method. This is also incorrect because logarithmic decrement is used to obtain the damping in case of free vibrations, not the forced vibration. Hence, this is incorrect. For the damped mechanical system, the amplitude of the vibration tends to become infinity when the excitation frequency reaches the system's natural frequency. This is also incorrect because, yeah, when the system is undamped, at that point, it is true that when the excitation frequency reaches the system's natural frequency, the amplitude of the vibration becomes infinite. But whenever we are damping the system, then uh, this will not go to the infinity. Okay, so this is true if it is an undamped mechanical system. The last one is the option D. Let's try to read it. The amplitude ratio and the transmissibility of vibration isolator is unity when the frequency of exciting force is √2 times the natural frequency. And this is correct statement because if you plot the transmissibility versus the omega by omega n plot, this will be like when omega by omega n 0, it will start from here, and then maybe depending on how much damping we are doing, ultimately at it will come back to 1. For all the values of damping factor, it will come at 1. So this is √2 comma 1. So basically at omega by omega n is equal to √2, irrespective of what is the damping coefficient zeta, we will have the transmissibility ratio as 1. So we can say omega is equal to √2 times omega n. Omega n is a natural frequency. Omega is the exciting frequency. So it's clearly mentioned that exciting frequency is √2 times the natural frequency. The transmissibility of the isolator is unity. Hence, yeah, there's a correct statement. So option D is to be chosen for this question. So that's all we have from this 2017 paper, set 2. Thank you all for watching this video.